very good morning to one and all. So now we'll start with the first session. It is renewable energy sources. So as you all know, the course is on energy management. First of all, why should we manage the energy? So we should know what are the different energy sources. Then we will go step by step into energy management. So there are conventional sources of energy also, like non-renewable sources of energy are also available. So like you have the coal, the petroleum products, the natural gas, and all those products which are depleting. But when you talk about renewable energy sources, they are not depleting. They can be replenished or they can be got again and again. So first of all, there are different forms of renewable energy sources. So we'll be going into that step by step. First, we will see what are the non-renewable source of energy, how they are formed. So we all know these fossil fuels, like millions of years ago, due to like some earthquake or some natural calamities, they were just buried under the earth's surface, and from there we get the fossil fuels. Even there are many natural gases and all things under the seabed, so they can also be got. So with a small video I'll be just showing you what are the conventional sources of energy, that non-renewable source of energy available, and why we go for renewable source of energy. So that is the first thing which you can see here.
Where energy comes from. The three major fossil fuels, coal, oil and natural gas, are all formed from organic remains of prehistoric plants and animals. These remains are subject to intense pressure over millions of years, changing them into coal, oil and gas. We often find oil and natural gas in similar areas, hundreds of meters below the seabed, though gas is usually found deeper still. Through seismology, it's possible to artificially create vibrations on the surface by using controlled explosions, and record how these vibrations are reflected back to the surface, revealing the properties of the rock layers beneath. Wells are drilled from a drilling rig to confirm the presence and quantity of gas in the rock, which travels up lengths of pipe once reached. If there is enough gas, the drilling rig is replaced by a production platform to collect and send it to the shore under pressure via pipeline. National Grid then takes the gas from the shore and sends it around the countryside through steel pipelines over 1 metre wide. As the gas gets closer to homes, the pipelines split into smaller ones, which may only be 20 millimetres wide. How electricity is made. Atoms consist of a positively charged central nucleus and negatively charged electrons, which float around the outside in much the same way as satellites orbit the Earth. When groups of atoms form materials, such as metals, electrons are free to move and flow, jumping between the atoms. These materials are known as conductors. This movement or flow of electrons is what we know as electricity. Power stations work by turning mechanical energy, movement, into electrical energy. A mechanical force turns a turbine, which rotates large magnets within coils of wire, and this induces electrical current, generating electricity. Electricity generators can be powered in a number of ways. Burning fossil fuels, coal, oil and natural gas, are traditional fuels but are harmful to the environment and cause climate change. Plutonium can be split to create nuclear energy. This method can produce huge amounts of electricity, but nuclear material is unstable and requires very careful management, and disposal of byproducts is difficult. Biomass is a renewable source of energy, including natural substances such as wood, organic waste, hydrogen gas and alcohol fuels. There are also other fuels which are renewable and are better for the environment. Wind power can harness the wind to turn the turbines and generate electricity. Hydropower uses the power and weight of water to turn the turbines. Solar power can also be used to generate electricity by capturing the sun's energy. National Grid can take the electricity generated from any of these sources, putting it into the network that eventually delivers electricity to homes and high streets around the country. Now,
So this showed you what was a conventional source of energy, And why do we go for renewable source? Because conventional source, you know that they are polluting, okay, and number of climatic change and all effects are coming into effect. That's why we go for, and they cannot be reproduced also. Okay, and coal and all, if you take around 2200, they may get fully extinct. So now we have to go for renewable source of energy. That is the need of the hour. But in renewable source of energy, what is the problem? In any renewable source of energy, when you do conversion, efficiency of the system is very less. Okay, and when you convert from one form to another, like say most of the renewable energy, if you take, is it solar, even wind, the output power is AC, but that AC has again been converted to DC, and then they do DC to DC conversion, then they invert and give it to the grid. So there also DC is involved. So any renewable source, if you take, if hydro also if you take, there mostly the output is DC, and that DC has to again be converted into AC. So when you want to do conversion, what is required there? Power electronic devices are involved. Those power electronic devices causes harmonics, switching losses. So there are lot of losses involved in all these things. So now our main aim is to improve the efficiency of such systems. So now we are just going to see what is renewable source of energy and what are the different renewable source of energy available. So renewable sources are natural sources that can be replenished in a short period of time. Within a short period of time, you can get it back, you can say otherwise. Or they are continuously available. That is the meaning here. They are continuously available. Like the solar, wind, water, geothermal, biomass. These are some of the renewable sources of energy. So first of all, let us see what is the power sector all over India. In India, what is the power sector? I think this is not visible much, so I'm just enlarging it. So this is the glance, Indian power sector at a glance. The total installed capacity as on December 2015, that is the latest thing. So the total installed capacity is 2,84,303. 2,84,303 is the total installed capacity as on December 2015, the latest megawatts. Okay, it's in megawatts. So you can see here the state sector is around 97,925 megawatt. Then the central, central is around 74,171, and the like the commercial, or you can say the private sector. The private sector is 1,12,207. So here now the private sector installation is more, because comparing to the previous years data, if you see, the growth of these private sector is more. Nowadays, even electricity is privatized, you can say. You have number of companies, is it Tata Power and Reliance, all they have also started generating power. So before it was under the government, now it is being privatized. So that's why you can see in the private sector also there is an increase in the percentage of installed capacity, and the total installed capacity is 2,84,303 megawatts. And the contribution by different fuels, if you take thermal, it is around 1,98,484. So the thermal, it is 1,98,484, out of which coal is 1,73,000 and 18 megawatts. Gas is around 24,473, and oil is 24,473 megawatts, and oil is 994 megawatts. This is the total thermal capacity. And now if you see renewable energy, hydro. So the hydro is the next, you can say, that is even used as the base plant, is it? Base load is mostly thermal and hydro. So you can see the hydro is around 42,623 megawatts is the installed capacity in India as per like 1 month back. Like this is 2015 December data. So the total hydro capacity is 42,623 megawatts, and nuclear is around 5,780 megawatts. That is also mostly used as a base plant. Many places, like many times that is also used as a base. And next, other renewable energy sources, like you have the small hydropower plants or the biogas gasifiers, even the wind, PV, and all those things together form around 37,415 megawatts. Okay, so other renewable energy sources, this. Now India is working on solar and wind. They are giving more stress on solar and wind. The problem why we didn't go into solar much was the efficiency of the solar system is very low. Even PV or thermal system, if you take, that is less. So now, but like government is taking more in, like they are giving incentives and they are taking more efforts that such projects has to be brought into picture. And if you see in Germany, Germany is the largest generator of this solar energy. They are the utilizer of solar energy. Okay, so we'll be seeing that in the later slides also. So now India also, like wind potential in India is more. So we are also moving towards wind energy generation. So this is the overall data, and here some of the installed power generation capacity, how it is increasing. You can see from this. See the renewable energy sources around 2010, you can see it had a very larger growth, and similarly the thermal has decreased. So the usage of thermal is nowadays, the percentage of usage of thermal is decreasing. And you can see this is the target. This is like the Ministry of New and Renewable Energy India. I have taken the data from there, and according to them, the wind power generation, like say 2022, in 2022, the target in megawatts is around 40,000 megawatt they want to generate from wind. Okay, so wind, because wind potential is more in India. So what the government has planned is by 2022, the R mega, like the target for wind is around 40,000 megawatts, and you can see here the solar also, it is increasing. But the target for 2012 was around say 5,000 megawatts or something. Now we are just planning for more than 10,000 megawatts by 2022. Okay, it's more than 10,000 megawatts of solar power is being plant, it is being targeted. Why we don't go for solar nowadays? Like still we are seeing, what is the main thing, like what is the power cost of generation for thermal and what is the cost of generation for solar? Any idea?
Solar is 60 to 80 rupees per watt for solar PV.
No, it's not so big. For thermal, it is say around 3 to 4 rupees per kilowatt.
Generation cost.
Generation, generation cost. I'm just for solar it is around 10 rupees, 10 to 12 rupees per kilowatt. Okay, so that's why like solar is little costly, but still why we go for it? Because it is not polluting. Okay, and it is naturally available. Yeah, it's a clean source of energy, and we know like the greenhouse effect and all the ozone layer depletion and all these things, we know it. So we want to go for green and clean energy sources. So many researchers are there in the field of solar and wind nowadays, which is being projected. Hydro is also there, because we know hydro projects are going on, and it has better efficiency also. Depending on the turbines, it has better efficiency, but still many projects are on solar and wind. So now we are going to this solar energy. So as we all know, the basic thing is nuclear fusion reaction inside the sun, which release huge amount of heat and light. So what this fusion reaction is, it is the isotope of hydrogen. You have two isotopes, tritium and deuterium. So tritium and deuterium, when they bombard with each other, large amount of energy is generated, and this byproduct of this tritium and deuterium is nothing but four molecules of helium and nucleus. So this will, during this bombarding, when these tritium and deuterium bombard, large amount of energy is generated, and that energy can be utilized by the at the earth's surface. So say solar energy received near the earth's space is 1.4 kilojoules per second per meter squared. So that is said to be the solar constant. So that is the energy which earth's surface is receiving, and it is continuous also, like continuously we are receiving it, but not throughout the year. Okay, so that is a disadvantage of solar system also. We'll be just seeing it later. So how to harness this energy in an efficient way? So that is what we have to see. So now next, some of the applications of solar energy, if you see, the solar heat collectors, solar cells, solar cookers, solar water heaters, solar furnace, solar power plants, all these are available. These are the different ways by which we can harness solar energy. So this here you can see a slide which is a solar furnace. Okay, so the solar furnace, if you see, This is a real-time picture of a solar furnace, and the other one here there is a small solar furnace. I think you can see it clear now. So this solar furnace, it has number of heliostats. These are the mirrors which are kept here, heliostats. Okay, so this solar light falls on it and it get reflected on a concave surface here. This is a parabolic mirror here, which is concave in nature. So when this solar radiation get reflected and falls on it, they are targeted on a particular area. This is the targeted area, which is a furnace. So there water gets boiled and steam is generated, and that steam can be used for generating electricity, or it can also be used for heating purpose also. That hot water can be used in a particular, say if it is a residential or some official office buildings, those hot waters can be used. So this is a small thermal system. You can see a solar furnace which is shown here. This is a real-time picture of a solar furnace. Okay, so solar furnace with, this is the targeted area and this is the concave mirror here. So this is one of the project. And next is, there are a number of small projects also going on. One is the Helios unmanned aerial vehicle, UAV. This is a drone vehicle, you can say. Even the like defense people, they use this for navigation purpose, to like detect when enemies are there, or like what to navigate and see what are the conditions. Even military people use this, and this is unmanned. This can be controlled by remote, or it is a unmanned vehicle. Another project you can see here is a Nuna 3. This is Australian students have made a car, Nuna 3. This is a single person can drive this, and nowadays more cars have come. This was the initial model which was which was given by the students, which was Nuna 3. So I say nowadays you have the solar rickshaws have come, solar cars, and many other projects have come, and we can also encourage our students to make such solar vehicles and such projects. And what you can do is you can make them connect to the grid. So that is the latest thing now. These solar vehicles, say nowadays we are coming from our homes. Okay, we bring a car, and our car is just standing here. If that can generate money for us, is it useful? If you say you have a car, and if it can generate energy for me, or it can give me money back, so what you can do, just make those cars with solar panels at the top. Make this car tops solar panels, you make it, and you have a station there, like say, which can and charging station. You connect to a charging station. So your car is here, and you have battery operated vehicle. If you make it as an electric vehicle, connect it to the charging station. Whenever you want to charge it. Otherwise, solar power is there, it will charge your battery. Whenever you want to give, say, excess, you feel that you have come at 9 o'clock, you're going at 5 o'clock. So around 9 or 10 o'clock, your battery is fully charged. So what you can do, that power which you have generated, you can give it to the grid. During the peak hours, give it to the grid. Okay, and in the evening when you feel, okay, I want so much power to go back home also. So what you can do, by that time, the program, nowadays everything programming is there. You can see that when battery is drained more than this amount, please stop giving to the grid and you charge your battery full. Okay, such mechanisms can be done, and this can be done in our institutes itself. First, you can give projects to students. You can just split it. Tell some students to make a hybrid vehicle with car, because many times when we say solar vehicle, we are coming, if it is it's a rainy day or you have not charged the battery, that's also a problem. So it should be an hybrid vehicle. So you can make the students do hybrid vehicles, and at the same time, so make some students make the charging stations. They will do it, and some people can connect it to the grid or connect it to your office. Okay, you can give connection to the office. So some of the labs or some of the rooms can be lighted by these energy. So this is also a very good project which we can implement in our institute. So next, residential solar power. You know that when we construct the house itself, we just plan it in such a way that we get natural light inside, and natural heating is also a process, and which we follow in our daily life. So next is the solar thermal power station. This is a project in Seville, Spain. Okay, so in Spain, this is a 11 megawatt project which was initially started. Okay, solar thermal power plant, 11 megawatts, which was the initial project. Now it is it is planned for 300 megawatts, and now 180 megawatts is completed. The same Spain project they have completed. This was only one station. This was said to be PS10. So and the PS10 had 11 megawatts. Then they had one more PS20 that had around 22 megawatts. And after that, number of small projects. They say they like this. This was first project. Then they had another project. Similarly, they joined number of projects, and it has a capacity of 180 megawatts. Okay, and they are planning for 300 megawatts by, I think, 2020. They will have mostly 300 megawatts. So this here you can see the solar thermal power plant. It has a solar tower here. So it has a tower here, and number of heliostats are placed down. So you can see this clearly now. Okay, sorry. So these are the heliostats. When sunlight falls on them, they reflect it, and here they focus on the furnace here. Okay, so here this is the lights are focusing on this, and here again you can see this is around 115-meter tall, and so it is surrounded by 624 reflectors. So these are the reflectors. Around 624 reflectors are there, and they track the sun and direct the rays to a heat exchanger at the top. So here this 2 is nothing but the heat exchanger. It will put all the, it will reflect the sunlight towards that heat exchanger. And receiver, there is a receiver, and that receiver converts the concentrated solar energy. The 2 is the receiver. So these are the heliostats which will reflect the light to the receiver here. That is a 2, which converts the concentrated solar energy from the heliostats into steam. Okay, so water is there converted into steam by this large heat generated. And this steam is stored in tanks. So here you can see the 3 tanks are there. These are the tanks here which you can see. So the steam is stored in the tanks and used for driving the turbine that will produce enough electricity for this 11 megawatt was for around 6,000 homes. So now the project is so big, it around 75,000 homes it can power. Okay, so this was a small project, this was the initial project. Now it has been expanded to around 180 megawatts. So this is the thermal power plant in Spain. So this is the PS10 and PS20 together power plant, thermal power plant. Then you have solar thermal power plant. Here this is also a particular model where here you have see the whichever fluid which has to exchange the heat. It may be water or maybe some other fluid which has the capability to exchange fluid, like exchange the heat. So that is being used. Once again, so here you can see this is a solar thermal power plant, and here this fluid flows through this solar collectors. So when sunlight may fall on this collectors, and the fluid which is flowing through these tubes get heated up, and they exchange the heat in the solar superheater. Okay, so initially say water is coming, and this water is pumped through some pumps, and here in the steam generator the cold water gets heated up and it exchanges the heat, and this steam will flow like this to the turbine. Okay, so this other water, it comes here and it is again pumped and it goes to the collector, and here superheating is also done in case extra heating is done, extra heat is required, and again they come back, and here in the solar superheater they exchange the heat. So this is for superheating purpose. The steam which is coming here, the cold water is getting converted to steam because of this fluid exchange is heat here, and this steam is superheated here again, and that goes to the turbine. It does the useful work, and steam once it do the useful work, it is converted into water, and again it gets condensed, and this process is continuous. And here you can see after the turbines you have the transformers, and again you required form you convert and you give it to the grid. So these are also the solar thermal power plants which are available. Okay, so next we are just going to this see the principle of a solar photovoltaic array. Okay, so the solar PV, if you see, there are two types, like thermal is also there and solar photovoltaic is also there. So what is the basic principle of a photovoltaic array? That is what we are going to see next through a video.
The sun. It is a unique, clean, and infinite source of free power, delivering more than 1,000 kilowatt hours per 1 square meter. 1,000 kilowatt hours is the amount of energy found in 100 liters of heating oil. Wouldn't it be wonderful if we could use the energy from the sun? Solar energy, wind power, and water energy are forms of very clean energy generation that can be converted to, for example, light. Photovoltaic systems use solar cells to convert solar energy into electrical energy. Solar cells are usually made of silicon, that is a semiconductor material, which means that it can conduct electricity under some conditions but not others. When looking at the periodic table, we see that silicon is part of group 14 and is situated between aluminum and phosphorus. That being the case, a silicon atom has 2 electrons in its first shell. It has 8 electrons in the second shell, but it has only 4 electrons in its outer shell. The outermost electrons are called valence electrons, and are of utmost importance because all silicon atoms consist of not more than 4 valence electrons. However, all of the silicon atoms will form bonds by sharing electrons to achieve a full outer shell with 8 electrons, which makes them very stable. In order to disturb the stable state, doping atoms are purposely inserted into the silicon. When boron is combined with silicon, 3 holes will be created because boron has only 3 electrons in its outer layer. With 5 valence electrons, phosphorus creates additional 3 electrons. And that's where the magic happens. A solar cell consists of 2 silicon panels sandwiched together. One layer is doped with N-type dopants, the other is doped with P-type dopants. To allow an electrical flow of electrons, a front and a back contact are installed to the layers. Glass is installed on top of it to protect the layers and the electrical contacts from damage. Now, it's time to take a closer look at the area between both layers. In the N-doped semiconductor, there is an axis of electrons. In the P-doped semiconductor, we observe positively charged electron holes. The electrons in one layer will find their corresponding free holes in the other layer. Consequently, an internal electrical field builds up at this transition that does not permit electrons and holes to jump into the other layer. However, if photons hit the silicon layers, electron-hole pairs will be created. If this happens in the electrical field, electrons are moved to the N-doped layer and holes are moved to the P-doped layer. The system will fall into a state of imbalance because of an excess of electrons in the N-doped layer. The corresponding holes can be found in the P-doped layer. It goes without saying that these free electrons and free holes try to combine. However, the electrical field does not allow such a condition. But if you connect the top layer to the other layer, for example by using a cable, you will see that electrons are traveling to the free holes. This flow is called an electrical current and can, for example, light a lamp. Solar panels can be installed on the ground or on your roof. The solar cells collect the rays of the sun and convert solar radiation into direct current, which is eventually converted into more usable alternating current by a piece of equipment called an inverter. Connected to the inverter is another device that is going to measure the electricity produced by the photovoltaic system. Generated electricity may then be reimbursed by your electricity supplier.
So we saw the principle of a photovoltaic. I think you understood it. Okay, silicon, and by doping, like with boron or phosphorus, you have the extra holes or extra electrons. So based on that, the silicon material is made. This PV material is made. Now what happens when photons fall on that? An extra electron or a hole is generated, and when you have a closed path, there will be a current flowing through it. So that is a basic principle which we have seen now. So same way here also, say here there is a small thing, say at our house rooftop. In our rooftop, you can have solar panels. When the radiation falls on these solar panel, they generate electricity. Okay, there's some voltage you get there across them. So that voltage can be used for our houses. If it is, say, if our house has DC load, directly you can connect it to the DC load. Yeah, so that's good. Like we have a project here also. Some students will be coming and showing you how to connect all these things, solar panels. Yeah, you can do it like this. You have a solar panel, sunlight falls on it, you get an output voltage there, and this voltage is not constant, is it? It varies with the irradiation. So what should be done? You cannot go and connect it to the load directly. So you have to store it in a battery. Okay, so for storing battery, what is the battery rating? Like what is the voltage rating of the battery? It 12 volts or 24 volts, not more than that, is it? So say for example you have a 12 volts battery, so you have to charge the battery. So this PV panel, say for example you have taken a some 37 watts PV panel, and your output voltage is around 17 volts. So this 17 volts cannot charge, you cannot give it to your battery. Battery may get damaged, is it? This yours, this 17 and this. So what do you require there in between? You require a regulator, or you can say a charge controller. Okay, that charge controller is nothing but a DC to DC converter. You would have heard about choppers. It's a chopper. It may be a boost converter, it may be a buck converter, it may be a buck boost converter or a cuck converter, anything like that. So buck converter, what it does, it will reduce the voltage to the required level. So here in this case which I said let us take the PV panel to be around some 37 watts. So if this is 37 watts and we are saying around 17 volts is the output voltage, and our battery is around 12 volts. So here in this case we require here a which converter? Buck. We require a buck converter here in this case. When you require a boost converter, any idea?
When the voltage will be lower, and the penetration will be small.
Okay.
Exactly the magnitude.
Okay, in the same place you are saying if the voltage here is say 10 volts. So in that case, here. So but you can't have a boost separately. Then when it is high voltage, it's a problem. So in this case, you will have here a buck boost converter. You will have a buck boost converter. When you require a boost, I didn't ask this buck boost or buck. I'm asking when will you surely go for a boost converter? That depends on the application, is it? When you want to charge a battery, you go for buck converter. When you want to have a situation that this radiation is very less, and that time also you want to charge your battery, and when the radiation is more, that time also you go for a buck boost converter. I'm asking when will you go for only boost converter? Any idea?
Heating purpose.
Heating, for induction heating or something you're saying, DC with DC. Say mostly when you want to connect it to a grid. Is it? Grid power will be a high. It is not 12 or 24 volts. There you will have inverter and you will be further giving it. But these, we want the maximum power from the PV and you want to give it to the grid. Mostly you go for boost converters there. Okay, so we have to first know depending on the application and depending on the situation, which converter to put there. And all these converters are nothing but the charge controller there. Okay, so you have the PV array, you have the charge controller here, and then you have, so here you can see, here you have the PV, you have the charge controller, and for DC loads directly you can connect to the DC load and you can charge the battery. But when when you have an AC load, say in a house we have an AC load, in such case you require what is called a inverter. You want to convert this DC to a AC. Okay, so many types of inverters are parallel inverters, series inverters, you have multi-level inverters. So in multi-level, so inverter is, say you have here a DC supply. That supply you are converting into a AC. So AC in the sense, first of all you get the DC, then you can reverse. So this is nothing but your AC. But this AC is not, it's not fundamental. Fundamental is not sinusoidal. It may affect your load. For such cases, what we do, you go for multi-level inverters. In multi-level inverters, what will happen? There also it is DC only, but you will have something like steps here. Okay, so you can have steps like this. Okay. It has not come so clearly, but anyway, I think it is understandable. So you get steps like this. So this will almost give you a fundamental AC supply. So now we have to see which type of inverter we require for our application. Whether, say, if it is the load is not so important load, and this 2-level inverter or a 3-level inverter, here 3-level inverter is also possible. For 3-level inverter, what we do, first we get the DC, then we have 0, and then we have again the negative. So this is also almost similar to a AC waveform. This is 3-level inverter, but this one is a 2-level inverter. So you can go for even multi-level inverters. So this is about the photovoltaic setup. So can you give me some researches in this field? What are the other research which can be done? One is the integration with the grid. You said when you want to connect this to the grid, आपको ग्रिड के साथ इसको कनेक्ट करना है, तो व्हाट इज रिक्वायर्ड देयर?
Frequency,
yeah, सिंक्रोनाइजेशन इज इम्पोर्टेंट. क्या क्या सिंक्रोनाइज होना चाहिए? आपका फ्रीक्वेंसी, आपका वोल्टेज, आपका फेज, सब कुछ सिंक्रोनाइज होना चाहिए. उसके लिए यू कैन यूज द फेस लॉक लूप, PLL फेस लॉक लूप यूज करके यहाँ जो फ्रीक्वेंसी NR है और लाइन का भी फ्रीक्वेंसी चेक करके when दोनों मैच करेगा, then you can give it. And another concept is always power will flow from higher potential to lower potential. Always the power flow will be like that. So हम क्या कर रहे हैं, से ग्रिड का 230 वोल्ट है और 440 वोल्ट. सोचो कि हमारे जो डिस्ट्रीब्यूशन में हमारे घर में आ रहे हैं 440 वोल्ट और 230 सिंगल फेज है तो 230. सो दिस से हम जो जनरेट कर रहे हैं ये 230 से थोड़ा ज्यादा ऊपर होना चाहिए, स्लाइटली. देन ओनली द करंट, बिकॉज ऑलवेज करंट फ्लोज फ्रॉम हायर पोटेंशियल टू लोअर पोटेंशियल. सो हम से जो ग्रिड के लिए पावर जनरेट करने के लिए सोच रहे हैं, बीइंग ऑल इलेक्ट्रिकल इंजीनियर्स, वी विल हैव एन आइडिया कि हम हमारे घर में क्यों नहीं बनाए. ओके, सो दिस यू हैव टू कीप इन माइंड. What you have to make, you have to make a inverter in such a way that, sorry, the whole setup in such a way that जो हमारे इलेक्ट्रिसिटी बोर्ड से पावर आ रहे हैं उससे थोड़ा ज्यादा रखने से ही हमारा पावर उस साइड फ्लो होगा. और इनकेस हम नहीं जनरेट कर रहे हैं से हमारा पावर नीचे चले जाएगा, ऑटोमेटिकली देयर विल बी अ फ्लो फ्रॉम द grid to our house. So these concepts should be clear. Okay, and many other research can also be done in this area. So many people are there, those are doing research. So आप लोगों के लिए मैं बोलती हूँ कि जो PV array है, can you tell me what is the efficiency of the PV array? फोटोवोल्टिक array का efficiency कितना है? 40%. 50. So generally हम से यहाँ जो अभी का चल रहे not more than 12 or 13. But research has been done, materials ये जो solar panels के materials में करके अभी 40 तक achieve किया है. Okay, maximum if you go and search in Google, Wikipedia में दिया है कि they have achieved till 40. So just research can also go on this field. आप PV के photovoltaic का जो efficiency है 90-95% लेके आ जाओ. That's a
solar tracking करके,
हाँ,
you can achieve it.
Yeah. No. In that case also, say जो एक सोलर पैनल है, यू जस्ट थिंक, यू आर टेलिंग कि ट्रैकिंग करके 50 अचीव कर देंगे, वो नहीं है। वहां से आपके पास एक सोलर पैनल है, कंपनी आपको एक सोलर पैनल दे रहे हैं, उस सोलर पैनल का जो कन्वर्शन एफिशिएंसी है वो 40 की ज्यादा नहीं है। ओके, उसमें क्या करना है, मटेरियल साइंस में अब पढ़ना है, यू कैन हैव थिन फिल्म की जो टेक्नोलॉजी है वो यूज करके। एंड इवन नाउ एमआईटी में एक प्रोजेक्ट चला था जिसमें उन्होंने क्या किया है कि दे हैव टेकन द लेड एसिड बैटरी एंड उससे एक सोलर पैनल बनाया है, उसका भी एफिशिएंसी 20-25% तक ही है। ओके, सो पीपल हैव प्रूव्ड दैट जो पीवी पैनल है दैट कैन गिव अराउंड 40% तक। सो आप जो एफिशिएंसी बोल रहे हैं ट्रैकिंग का, ये जो हम इस सोलर पैनल को लोड के साथ कनेक्ट करते समय और भी एफिशिएंसी कम हो जाएगा। Efficiency of the solar panel is 40. There is a maximum if you take it as 40 also. But now in market now, if you go around 14-15% की ज्यादा नहीं है, but maximum say 40% if we take it also, that 40% should also go to the load, is it? You're tracking the, you're getting the efficiency, sir, you're getting the solar power, उस power को आपने electricity में convert कर दिया, आपने buck boost और कुछ converter डाल दिया, वहां भी drops है, losses है। So when it goes to the load, total efficiency देख लिया तो ये 40% के भी कम ही मिलेगा। So उस केस में ट्रैकिंग में हम क्या बोल रहे हैं कि ये जो 40% जो एफिशिएंसी पैनल का, वो पूरा पावर 100% शुड गो टू द लोड। वहां हमारा 100% लेके जाने में उसमें भी 80-90% तक रिसर्च हुआ है कि ये जो 40% है, अराउंड 40% जो एफिशिएंसी पूरा इलेक्ट्रिकल एनर्जी में कन्वर्ट हो सकता है, तो दैट इज द अचीवमेंट। Okay, so there's tracking, as you said, that was a very good thing कि tracking में भी बहुत सारा scope है। We can make our students and we can also do research in the field of tracking. So tracking भी बहुत तरीका का है। You have mechanical tracking, you have electrical tracking. The one which you were telling now is the mechanical tracking. What you do, solar panel को हम first initially like sun की position east or west देख के लगा देंगे, and you will have some sensors there. As the sun's position changes, automatically the solar panel will start rotating. You have some motor arrangement. You can have a stepper motor or some servo motor, and slowly, according to the, तो भी sudden variation नहीं है. Slightly sun का position, you itself will not know when it is moving. So slightly it will go to the other position, and you can track it. Another thing, the main problem in this mechanical tracking is, already आपको जो electricity मिल रहा है, ये motor को run करने के लिए again you have to give it. It's a waste there. So can you think of something that जो maximum efficient जो मोटर है उसको भी रिमूव कर दो, इसको उस पोजीशन में रखना है जो मैक्सिमम एफिशिएंसी देता है।
सैटेलाइट पावर सिस्टम,
सैटेलाइट
पावर सिस्टम,
हाँ,
उसमें 24 आवर्स वो रहता है।
वो तो उसकी पोजीशन वहां है ना, दैट ऑल्सो वी विल बी सीइंग। ऐसे एक प्लांट भी मैंने लिया है, बट ये देखो ये क्या करेंगे हम, व्हाट विल वी डू, we will just go and search for the latitude and longitude of a particular position. से चंडीगढ़ है, उसके लिए एक latitude and longitude होगा, जिस position में solar panel रखने से आपको maximum efficiency मिलेगा. So that is one thing. In that position, excuse me, in that position also, you have to get maximum in the sense, you have something called electrical tracking. एक principle है electrical tracking का. उस principle के accordingly क्या करेंगे, I can just show you that. So electrical tracking में हम क्या करेंगे, say you have the solar panel, इस solar panel का output को आपने एक charge controller दे, यहाँ जो charge controller वही है, say I'm having here a buck or boost converter or something, okay, and you have the load here, any type of load, say यहाँ DC load ही ले रही हूँ because it's a DC to DC converter. I'm just considering this as a DC to DC converter. Okay, is it clear? So now, when will maximum power transfer from this source to load? कब transfer होगा? Electrically think करके बताओ कि कब maximum power एक source से load में transfer होगा?
मैम इंटरनल रेजिस्टेंस
impedance match होना चाहिए according to maximum power transfer theorem. Whenever the source impedance is equal to load impedance, maximum power will transfer. So उसके लिए अभी electrically भी track कर सकते हैं, impedance matching करेंगे। उसके लिए हम क्या करेंगे, we'll have some controller here, okay, उस controller से आप इसकी जो यहाँ की जो voltage है, उस वोल्टेज को ट्रैक कर लो, इस वोल्टेज को ले लो, इस वोल्टेज को दे लो यहाँ, और सिमिलरली इस करंट को ट्रैक करो, इसमें करंट को भी दे दो। ओके, वोल्टेज एंड करंट दे दिया। इस वोल्टेज एंड करंट के हिसाब से आप यहाँ एक ड्यूटी साइकिल इस बक बूस्ट कन्वर्टर को डिस्टर्ब करके एक ड्यूटी साइकिल दे देंगे। Okay, so this buck boost converter will get disturbed there, and here at that time इस impedance और इस impedance को हम मैच करवाएंगे। Okay, actually वो क्या है कि you have to draw the like characteristics, then you will understand clearly. So if characteristics of a PV array आप देख लिया तो it is something like this. Say this will be your P and this will be your V. So हमारा मेन काम क्या है मैक्सिमम पावर ट्रांसफर थ्योरम में, और अकॉर्डिंग टू MPPT this point is required. This is the point required. This is the maximum point at which impedance will match. So हम क्या करेंगे, से ये वोल्टेज एंड करंट है ना, इस दोनों को हमने मेजर कर लिया. We have measured this voltage and current. Now what will we do? Say that voltage and current is this. Just think कि इस point में मेरा voltage ये था और मेरा current ये था. Okay. So now what I am doing? Is this my maximum point? No. So what I'll do? I'll change the duty cycle of this buck boost converter and again note what is my voltage and current. So my new voltage and current is this. Okay. So let me keep that as one V1 and I1. अभी ना वो मैक्सिमम पावर अचीव कर दिया नहीं है. How did and whether we can achieve it or not, how will we know? When it is increasing,
Yeah, exactly. With increase in voltage, if it is rising, it means
you can achieve it. Okay, if it is decreasing, you mean that you are going down the slope. When it is going up, you say that you can still go up and reach it. So अभी इस point reach हो गया, we have reached. Still again what you do, you change the duty cycle and still go up. So उस टाइम वो up नहीं जाएगा, वो नीचे चले जाएगा, इस point मिलेगा. So we have the voltage as the current has decreased there, or voltage has decreased. That means that you have crossed the maximum power point. So go back to the पहले का point. So इस point को आप ऐसे, this point को आप track कर सकते हैं using electrical tracking methods. Okay, this method is said to be perturb and absorb. P and O. This is perturb and absorb method. You have incremental conductance. उसमें क्या करेंगे, इसका slope draw करेंगे. Positive slope है, you can go up and achieve it. Negative slope है, this is negative slope. So you have crossed the maximum point. So that is incremental conductance method. So ऐसे बहुत सारा methods है इस maximum power point को track करने के लिए. उस maximum power point कहाँ है? The place where the impedance matches. वो impedance matching हम कैसे करवा रहे हैं? By using this buck converter, जो charge controller है उसकी duty cycle को हम change करके we can make the input impedance match the load impedance. I think it is little clear now, or should I explain it more? So इस field में भी बहुत सारा research है. You can go for different tracking techniques. Perturb and absorb, incremental. Nowadays you have artificial intelligence based, fuzzy logic based, ANFIS based, and now optimization based. What they are doing is optimization में first time ऐसे करके एक maximum power track करेंगे. Okay, so this will be said to be the local maxima. फिर क्या करेंगे, उस point को base रख के particle swarm optimization और GA कुछ और optimization algorithm use करके they again find the global maxima. Okay, those optimization algorithms will help you to find the global point, global maximum power transfer point, maximum power MPPT point measure करने के लिए you can use optimization technique also. That is also a field where you can do lot of research. इसके बिना एक और place में आपको research कर सकते हैं, that is partial shading. इसमें क्या है कि when there is a cloud coming here, से आप सोचो कि यहाँ आपका बीच में एक cloud आ गया और आपने जहाँ ट्री रखा है वहां एक ट्री, सॉरी एक पैनल रखा है वहां एक ट्री है, क्या होगा, बेस्ड ऑन द सन्स पोजीशन सम शेड में कम इन दिस. ओके, ट्री को तो हम कट भी कर सकते हैं, but एक cloud है तो what will you do? Okay, the other problem is solar panel तो हम रख देंगे, every day जाके clean नहीं कर पाएंगे. So when dust will come on that. So all these are the problems which you face with the solar panel. So there you have partial shading. Partial shading based MPPT algorithms are also available. Partial shade हो रहा है तो भी उसमें से भी maximum power कैसे हम track कर सकते हैं. So you have a lot of scope in this solar power because till now we have not achieved the maximum efficiency. आप इस 40 जो बोला था मैक्सिमम अभी रिसर्चर्स ने फाइंड आउट किया है उसको 90 तक लेके जाओ यू विल गेट नोबेल प्राइज इन दैट बिकॉज वी आर इन द नीड नाउ. आप एफिशिएंसी को इंक्रीज करके दिखाओ आपको श्योरली मिलेगा बिकॉज नाउ द होल वर्ल्ड इज रनिंग बिहाइंड दिस सोलर पावर एंड उसकी एफिशिएंसी कम है उसके सो श्योरली तो उसमें रिसर्च है रिसर्च स्कोप है सो यू कैन हैव लॉट ऑफ रिसर्च इन दिस फील्ड ऑफ सोलर पावर. ओके, this was you were also telling about space key. So this is an orbital solar farm which is under research. 2030 में ये project reality में आ सकता है. Okay, it is a Japanese aerospace exploration agency. They have this orbital solar farm. Okay, so geostationary solar panel है हमारे like this is in Tokyo में they have made around 3 kilometers का एक island बनाया है. उस island में they have, see I can show you, this is the thing. So they have around 5 billion tiny reflecting antennas which can convert microwave into DC electricity. So they have made a small island and that island they have this 5 billion tiny rectifying antennas are kept. So this is the solar power plant. And this project, Japanese agency like Japanese aerospace agency at exploration agency have taken this, and this is a 1 gigawatt plant. Okay, and this around 2030 for till 2030 this will come into reality. And here you can see these are the reflectors and this is the solar panel. यहाँ जो white color में दिख रहे हैं these are the solar panels. Okay, and these are the mirrors which reflect the solar light on them. Okay, and this is in the space, that is geosynchronous orbit में a placed है. So giant solar collectors in geosynchronous orbits are beaming the microwave down. So ये microwave में convert करके this is being beamed down to that Tokyo man-made island. It is a man-made island they have made there, and this is being beamed and it is coming. And यहाँ ground में जो ground station है, there are 5 billion tiny rectifying antennas there which converts this microwave into DC electricity. So here also lot of scope is there. If you can do research in the field where microwave को DC electricity में convert कर सकते हैं there, because अभी जो first initially कर रहे हैं efficiency कम होगा, you can do research in that field where microwave can be converted into DC electricity, and that DC again, see here you have the converter, that DC is converted into AC and it is given to the grid. So this is also a main project which is going on. It is around say 36,000 kilometers above from the earth. So usme again many problems are there, climatic thing, and it may affect the atmosphere. All these researches are going on. So here also in this field also you have lot of scope for research. Next is here you can see Daniel Nocera. So he is being considered by the Times magazine as one of the 100 most influenced people on the planet. Why? He has invented a leaf. वो जो leaf है, he has invented a leaf which can store energy, for which can perform photosynthesis. So आप सोचो कि अभी एक leaf जो real time leaf है उसको invent कर दिया, which can do photosynthesis, which can store electricity in that, or which can store solar energy in that. That solar energy can be used for generating electricity. So future में हम सोच सकते हैं कि ऐसे solar like ये जो transmission lines द्वारा नहीं होगा, जो sun की like ये जो man-made leaf है उससे हम electricity generate कर सकते हैं. उनके एक और project था, in that solar energy को use करके ही with water we can generate electricity. Okay, to little water. So that is it. When he was working at MIT में when he was working, this project was launched. So इसमें क्या है कि say you have the solar power, solar panels there. Morning time में from the solar power you just illuminate your office or your house. Okay, and at the same time जो excess energy है solar power, it will be taken to this electrolyzer. You can see here electrolyzer, and there this water is converted into hydrogen and oxygen. Okay, जो hydrogen है, that hydrogen is used in the fuel cell along with oxygen to generate electricity. Okay, so this fuel cell will be operating. This can hydrogen and oxygen. Hydrogen is there, and you have a membrane there, and this oxygen, when it reacts with this hydrogen, again the byproduct is water. So water जो generate output product है, that can be given again back to this electrolyte, and again it can be split. So this is a cyclic process. So अभी क्या है कि the fuel cell, what it will do during the night time, that can be operated. इसे डे टाइम में सोलर की डायरेक्ट एनर्जी जो रेड कलर है वो डे टाइम में यूज कर लो, आपकी घर की लाइटिंग के लिए भी यूज कर सकते हैं, हाइब्रिड व्हीकल्स को भी आप इसके साथ कनेक्ट करके आपका चार्जिंग कर सकते हैं. ड्यूरिंग द नाइट टाइम द फ्यूल सेल विल स्टार्ट ऑपरेटिंग एंड दैट कैन पावर योर cars as well as your house. So this is a project that is also like here also lot of researches are going on. You have lot of scope in this area also. Okay. And this is solar settlement. As I already told you, Germany is a company. Germany is the place which is harnessing maximum solar energy. Most of the Spain में जो हमने project देखा है, that is that, and many other projects solar की base ही Germany है. Germany में बहुत सारा projects available है. Okay, so this is the solar settlements. You can see जो houses है उसके पूरा ऊपर solar panels लगा दिया. So full house is being powered using this solar energy. And this is also a photovoltaic SUDI shade. Okay, this can also be implemented in our campus. Is it? आप मैं वही बता रहे थे कि हम जो कार लेके आते हैं, that can be charged. वो एक है कि हमारे कार के ऊपर ही सोलर पैनल रखा सकते हैं. Okay, that is one thing. और जो shades है, we always search like हमारा कार कहाँ जाके डालना है, एक shade में डालना है. That is what we search, is it? So if that shade itself is made up of solar panels. So if you have some ideas, आपके वहाँ से DST projects or कुछ देना है, you can even think about this. Okay, so this shades will be of solar panels, and उसको hybrid vehicles को charging station भी बना सकते हैं. उसको एक charging station बना सकते हैं. जो excess power आ रहा है उसको आप grid में भी दे सकते हैं. So this is also a very good project which you can think about. सोलर ट्रैफिक लाइट्स, वो तो इंडिया में भी अभी है. बेजिंग का फर्स्ट चाइना में था ये सोलर ट्रैफिक लाइट. सो उसकी पिक्चर है, बट नाउ in India also in every places almost it is solar powered. So you can see here, and this one you would have come across, solar impulse 2. Did you hear about this? News में भी अभी recently आया था. So Andre was driving this plane, and it was for 4 days 21 hours and 51 minutes. That is the longest drive which they have done with the this is a solar aircraft. Okay, fully powered with solar. So they have achieved 4 days 21 hours and 51 minutes continuous drive they have done with this. So this is one of the achievement in solar panels on the International Space Station. So you would have come across the International Space Station. वहाँ भी पूरा it is powered using solar power. And grid connection of photovoltaic power system. That is also a very important or main area where you can see the solar panels, like you can have micro inverters. So अभी क्या concept है कि in many countries they have started house. In our house, so आपके own use के लिए you have solar panels, you generate your electricity, okay, you use it, जो extra energy है give it to the grid. Okay, in case आपके पास नहीं है, you can even get it from the grid. Okay, so but when you give it to the grid, you will be selling it at lower price. Grid may give you at higher price. That is there, but still you can generate your power and give it to the grid. So what is required in between there? Conversion is required. And the other thing is meters. Say grid से भी आप power ले रहे हैं और grid में भी दे रहे हैं. What is the authenticate? Like something should be. So you have smart meters nowadays, bidirectional smart meters, which will just calculate, which will just calculate how much power you're generating and you're giving it to the grid, and how much the grid is giving you. And you have some electronic systems which will calculate your bill also. So such systems can also be thought about. So here, so micro inverters, like micro inverters are being kept here. The reason is ये individually houses हो सकते हैं, and power converter जो DC है उसको AC में convert कर दिया, loads में directly दे दो, otherwise you can even give it to the grid using bidirectional meters. Despite all these facts, solar energy is totally pollution free. We know that, and it is available in abundance, but commercially popular because of the following shortcomings. It is not commercially popular. Itna hai, but फिर it is not commercially popular. The reason is solar radiations are rare, and collection of solar energy is very costly, and radiation is neither uniform nor continuous. And the other important reason which I told you is the efficiency. इसकी efficiency कम है. Okay, so that is also a main reason why we don't go for it. But still nowadays, the research is into it, and many, like say even Chandigarh, the solar city, they are trying to implement in our college also around 50 kilowatts ka ek plant laga diya hai, and in all the government buildings you can see they are
There is also 100 kilowatt.
okay, 100 kilowatts. So all those researches are going on now. Number of in all the places they are trying to go for solar. Okay, so those things are there. Still, what we can do is how to improve the efficiency, और जो existing system है उसकी efficiency improve करने के लिए, और overall system की efficiency increase करने के लिए we can work on. So that is the solar. Next is wind energy. So India's potential for wind energy is more. So now we are also in India many projects are going for this wind projects, the fastest growing source of renewable energy, and this wind energy, it didn't start nowadays. It started from 5000 BC. बहुत पुराना है, and usually if you see, it was used for generating electricity in Denmark in 1890. That was the first like electricity generation के लिए in 1890 में शुरू हुआ था. And this wind energy is also a form of solar energy, because heat, जो atmosphere की heat difference के कारण ही ये wind flow होता है, is it? And it is caused by uneven heating of the atmosphere by the sun, irregularity of Earth's surface, and rotation of the Earth. So all these things are causing the wind, and the amount of speed of wind depends on the Earth's terrain and other factors. So there are two types mainly. If you classify the wind turbines, they may be horizontal axis or vertical axis. So the horizontal axis आप अभी देख सकते हैं. This is the horizontal axis, and this is the vertical axis. So vertical axis में क्या है कि जो rotor है और जो मोटा like जो generator है वहाँ, that is kept in the vertical position. Okay, and there the shaft is not directly coming in contact with the wind. So that is the efficiency of this. That is the advantage of this vertical axis system. Even in low wind speed, this is producing high efficiency, like a high more energy. Like efficiency is more even in low wind speed. But the problem is it occupies more space, and like you can see the structure here, it requires support. So these are some of the disadvantages. But still, if you can see, vertical axis wind turbines are like even they are efficient for low wind speed also. So these are the different things. Say these two. This is also vertical axis. ये भी vertical axis है. जो गिरो मिल, this method, वो जो हम बोलते हैं ना, like egg beater. So egg beating thing. So such a windmill. This is also a vertical axis wind turbine. Hai. This is a modern horizontal axis wind turbine, and this is a Savonius vertical axis wind turbine. So these are the different wind turbines. So here you can see this is a horizontal axis wind turbine, and this you can see here. Mainly nowadays the wind turbines also, उसमें भी बहुत सारा research चल रहा है, and now they are intelligent wind turbines we say. Because depending on the wind direction, wind speed, they change their yaw and they change their pitch. The blade भी अपने आप, जैसे यहाँ you can see here. Here you can see इसका direction, the blade का direction भी change हो सकता है. This is the pitch we say. Pitch direction change कर सकते हैं. At the same time, yaw. This can also change depending on the wind's direction. Okay, you have the yaw motor. This is said to be the yaw motor here. So yaw motor will change the direction. Yaw direction change कर सकते हैं. Similarly, pitch of this blade can also be changed. So nowadays, many algorithms, MPPTs, maybe maximum power tracking algorithms are going on where you can track maximum power. So here you can see the rotor. This 2 is the rotor, which is there inside. You have the blades, and this 5 is a low speed shaft. So first, initially, this rotates as a low speed that is being converted into high speed using gearbox arrangement. And this 7 is the generator. Okay, so this is the generator, and you have, this is the anemometer here. The 9, which you can see, is which measures the wind speed. So depending on the wind speed, it changes its yaw and the pitch, and it can generate maximum power. And this picture which you can see is a real time. एक रियल टाइम विंड टर्बाइन का पिक्चर है. So this is the real time. उसकी इसमें से remove करके you can see all these arrangement. Okay, so this is the original wind turbine. So actually this wind turbine, if you see, that generates electricity in the form of AC. So that AC cannot be directly given to the grid. First of all, some conversion is required. This AC is also not continuous, as I said. It is a varying AC. So what we usually do, we convert that into DC. So DC to DC conversion से again DC को AC में convert करके you can convert according to our requirement of frequency, because 50 hertz is required, and whichever transformation has to be done, that is done, and then it is again stepped up or stepped down using transformers and then given to the grid. So advantages and disadvantages of wind mills, if you see, wind is free, okay, and wind farms need no fuel, so that is the advantage, and produce no waste or greenhouse gases it doesn't produce, and the land beneath it can be still used for farming, for other farming purpose also you can use this, and this is a tourist attraction also. Many places when they have windmills, we either just go and visit them, and good method for supplying energy to remote areas. When there is a remote area where the grid is very far, then you can go for these windmills. And can you tell me, like, एक windmill का कितना capacity है? How much it can generally? एक windmill you would have seen in Rajasthan, many places में है. One single windmill can generate how much power?
It can go up to 2 megawatt also.
Okay, 2. It can go up to till 5 megawatts. 5 megawatts. Okay, one megawatt का है, for 2 भी है. 5 megawatts तक एक single windmill का जो structure है, it can give up to 5 megawatts. So not always, this wind का है कि it is not always predictable, and land price. इतना big area of land में you have to go and install it, so that land price and changing landscapes, it can kill the birds, and it affects the television reception near the nearby living area में, or noisy भी है. You can have an humming sound always, you can hear it. So these are some of the disadvantages of windmill. Can you tell what is this? Have you seen this?
Looks like a building.
What is this? Bricks है? Any idea about this? Solar plates, that is थोड़ा आपने आ गया, that is also correct. Solar plates are there. Then ये क्या चीज है? At least उसके आसपास देख के आपको पता नहीं चल रहा है.
It looks like a building.
It looks like a building. It's a building. Okay. This is a skyscraper in Dubai. It was constructed in 2010. And this building is a rotating building. And ये एक बार जो shape देखा है वो lifetime में दोबारा देख नहीं सकते. Might be देख सकते हैं in case वो ऐसे wind condition है everything आ गया तो. So here you can see this is a different location, different time में जो photos लिए हैं आप देख सकते हैं कि this has different shapes. It changes according to the wind speed. So this architect of this was David Fisher. He is an Italian architect who did this, and 2010 में complete हुआ था. This is a commercial building. It has number of offices, houses भी है उसमें, and ये जो rotate होता है, it is at very slow speed. So we will not know it. And जो small change in speed है, उसको gear arrangement करके they are generating electricity. And this whole building is getting power from by itself, by its rotation and the solar panels on its like इसकी जो outer surface है उसमें solar panels लगा के उसमें से मिल रहा है. It is not using any other external power source. Okay, so you can just see a video of this.
Is it the skyscraper of the future? or just a pie-in-the-sky idea. Italian architect David Fisher unveiled in New York Tuesday the design for what he's calling the world's first building in motion. It's an 80-story residential tower with revolving floors, ostensibly set for construction in Dubai this fall.
It's the first building that is dynamic, changing the shape. You can adjust the shape the way you like every given moment.
Fisher says he is also slated to build one of the dynamic buildings in Moscow, and he hopes New York City. He says the buildings also double as generators. Wind turbines on every floor will provide power.
This building is completely self-powered. Wind has a very negative effect on skyscrapers, we all know. And I say, why do we want to find the wind? Let's use the wind, for our benefit.
The Dubai condos are going for $3,000 a square foot. Lifts will allow penthouse residents to park their cars right in their condominium. Fisher says the building parts will be prefabricated in a factory in Italy and then assembled at the final location. The architect says he'd like to have the Dubai building ready to live in by 2010.
So
Ted Shaffer, The Associated Press, New York.
So this has come into reality in 2010, and now in Moscow also they are building such a building. So now you can just think, now we are all going to renewable because that is the need of the hour. Okay. And this is one more magnetic levitation based wind turbine. So हमने जब अभी we were just talking, one windmill can give maximum of 5 megawatts. One, like in case if we take 1 megawatt, आप सोचो 1000 megawatts is equivalent to one magnetic levitation wind turbine. So this magnetic levitation wind turbine, it uses 100 acres. जो windmills हमने यहाँ देखा है, दूसरा जो conventional है, it takes around 64,000 acres. So within 100 acres itself, it's a very big arrangement, and this is a magnetic levitated wind turbine, and it can power around 750,000 homes. And this around say 1,000 standard windmill can only power 500,000 homes. And this windmill, if you see, it is based on the principle of magnetic levitation. Have you heard about this magnetic levitation? Okay, so like हमारे यहाँ student ने भी एक magnetic levitated arrangement किया था. I'll just show you the video. So here the same principle is there. So उसमें ये है कि this magnetic levitated wind turbine का advantage है कि there is no friction in this. जो एक portion है, this is a neodymium magnet is used there. Usually हमने यहाँ जो बनाया it is an electromagnet, but here it is a permanent magnet. And it has no friction, it has no touching, it is not touching with other portion, and it goes on rotating. And इसके rotate करने के लिए only 1.5 meter per second speed is required. And even till 40 meter per second speed maybe, this will give you the efficient efficient power generation. So even कम power से slightly इसको rotate कर दिया, it will go on rotating. That is the advantage of this magnetic levitation wind turbine. So now this is also a project. I don't remember the place, but you can just go and search in Google for this magnetic levitated wind turbine. So this magnetic levitated wind turbine is like in future, if you see, surely it will replace all these standard wind turbines. Okay, so our student had made this project. You can see this. So हमारे यहाँ lab में हमने बनाया है. This is an electromagnet. Okay, and this is an electromagnet, and here this is also a magnet only, permanent magnet. उसको like weight proper होने के लिए हमने एक battery उसमें attach किया है, but otherwise battery इसको नहीं चाहिए. This is a permanent magnet only. वो proper correct weight है तो ही वहाँ वो suspend होगा. So you can see there without any contact. इसको slightly हमने turn कर दिया, ये rotation में चले जाएगा, and it will not stop. That is the thing here. Slightly उसको एक force चाहिए, that's all. Once it gets the force, then automatically it will go into rotation. That's why I said even that big windmills which you saw there, the magnetic levitation windmill हमने जो दिखाया था, that requires only a small push. 1.5 meter per second की wind speed ही required है. Once it goes into rotation, it will continue in rotation because there is no friction. Same principle many other applications के लिए. In places where you want to stir some chemical which is like hazardous, कुछ और material नहीं डाल सकते और हाथ डाल के, like human cannot interfere. In that place also say उसके स्टार करने के लिए भी this magnetic levitation principle can be used. And now in the field of wind also, nowadays people are going behind these windmills, like magnetic levitated wind turbines. Okay, so that can also be done. Next is hydroelectric power. So like India's leading renewable energy source, like we know that hydropower is being used as the base load for of India. So hydroelectric power we are going to see. So the earliest reference from 4th century BC Greek. It started, and it's a Greek word. Hydro means water in Greek. Okay, so it started from the 4th century, and now if you see hydroelectric power using the potential of energy of rivers, it is 17.5% of the world's electricity is obtained from this. So you can see that world ke jo pura world ke 17.5% of the electricity is generated by hydroelectric power, and this is 2013 का data है. 99% in Norway, 57% in Canada, 55% in Switzerland, 40% in Sweden, and 7% in USA. Even in India, if you see, we are also dependent on this hydro. And water flow, like as such here, as you know, hydra, like we have the dams, higher potential, like water is stored at higher potential in the dams, and it is made to flow through the penstocks. So here, this is the arrangement. Here, the reservoir is there, the dam, and penstock se pani it comes and it rotates the turbines, and it goes like downstream में river में चले जाएगा, and this can be used for generating electricity. So we are getting short of time, so एक और video है. Okay, just you can see this video. Niagara Falls. This is Niagara Falls, and they are showing how
170,000 cubic meters of water flow past here every minute at almost 60 kilometers per hour. That's enough water to fill about 100,000 Olympic swimming pools every day. Standing here, you can actually feel the power of the water. Harnessing that power is what hydroelectric stations have been designed to do for over 100 years in Ontario. In essence, they are factories that convert the energy of falling water into the flow of electrons, or what is commonly called electricity, the electricity that powers the province. Most hydroelectric stations use either water diverted around the natural drop of a river, such as a waterfall or rapids, or a dam is built across a river to raise the water level and provide the drop needed to create a driving force. Water at the higher level is collected in the forebay. It flows through the plant intake into a pipe called a penstock, which carries it down to a turbine water wheel at the lower water level. The water pressure increases as it flows down the penstock. It is this pressure and flow that drives the turbine that is connected to the generator. Inside the generator is the rotor that is spun by the turbine. Large electromagnets are attached to the rotor located within coils of copper wire called the stator. As the generator rotor spins the magnets, a flow of electrons is created in the coils of the stator. This produces electricity that can be stepped up in voltage through the station transformers and sent across transmission lines. The falling water, having served its purpose, exits the generating station to the tailways, where it rejoins the main stream of the river to continue the cycle of creating clean, renewable energy for Ontario.
And hydroelectric dams के advantage and disadvantage देख लिया तो advantages, the energy is virtually free, no waste or no pollution is there, and it is reliable and can cope up with the peak demand and can increase the full power very quickly, unlike other power stations. That's why here base plant उस reason के कारण use किया, electricity can be generated constantly. Some of the disadvantages, it is expensive to build. Okay, and then the environmental constraint downstream and upstream, flooding हो सकता है, or like many other problems are also there because of this dams. Okay, so that is the main disadvantage. So this is a pump storage plant. This you cannot say this is in generating like इसमें क्या है कि when during the non-peak hours, when electricity का जो cost कम है non-peak hours में, उस पानी को हम पंप करके ऊपर रख देंगे or during the peak hours when the electricity's cost is more, you generate it. Okay, so this is actually not a generating station. You can say this is just a storage. When we want it, like say अभी जो electricity दूसरा form में है, we can store it in battery or some other form. But जो इस form में, like from the hydro, you cannot store the energy and keep. Okay, so ये एक storage plant है. This is not a generating plant. Actually, it's a storage plant. During the non-peak hours, हम उसको pump करके रिजर्वायर में रख देंगे, and when it is the peak hours, जब electricity का cost ज़्यादा है, उस time हम उसको generate करते हैं. Pump storage plant का advantage है कि little effect on the landscape and no pollution or waste. That is hydro का same वही है. Disadvantage है कि it is very expensive, and say once you have once it's used, you cannot use it again until you have pumped the water back up. से आपने पंप करके ऊपर नहीं रखा तो फिर वो यूज ही नहीं है. So you have to pump it. So other cases में वो naturally we are collecting the water. Here you have to pump it. So that is a disadvantage of this system. Next is from ocean. So ocean energies, you have different forms like waves, tides, ocean current, ocean thermal effects. So from there also you can collect electricity. So ocean में आप देखते समय, and as we all know, around 70% of the Earth's surface is covered by ocean, and even 0.1% उसमें से हम energy extract कर दिया, that is more than enough for the whole mankind. That is what we are saying. And depending on the location also, you can extract this ocean energy. So one of the form is you have attenuators. You have something like flaps. वो ऊपर जाके oceans में डाल दिया. That motion of those attenuators, up and down motion, can generate electricity. Similarly, you have the point observers. So you can see the point observers here. Also, they are like जो sea bed है उसमें construct कर लिया, and you have ऊपर आके एक pointed एक observer है. So that may, depending on the wave motion, move up and down. So that mechanical energy can be converted into electrical energy, and through like underwater cables you can transmit it. Next, submerged pressure differential. So इसमें क्या है कि जो rotor, like the moving part hai, that is submerged in water. In the last case mein to it was up, like it was not submerged. It was not submerged in the water. It was floating in the water. But in this case, it is submerged. Next, you have this flap type. So it is an oscillating wave surge converter. So here, this is also submerged type, and it is oscillating. Another is oscillating water column. So in this oscillating water column में आप देखते समय जो पानी है, this it will enter from this duct here and it moves up the column. When it moves up the column, the turbine here rotates, and that can be used for generating electricity. Similarly, you have one more time overtopping device. So overtopping device के इसमें है कि जो ocean की waves हैं, उस waves it will move over the structure, and it comes down a column where there is a turbine. So this can also be used, and the jo excess water again it is sent back to the ocean or sea. So this can also be used for generating electricity. So there, like from ocean also we generate electricity from the waves which is produced. दूसरा है कि tidal भी है. Tidal में है कि high tides and low tides. ये ऐसे नहीं है, waves से है. Just जो general waves हैं उससे भी हम generate कर सकते हैं. So wave power. Waves push high pressure on oil through, like even hydraulic motors can be used to generate electricity, and it can be taken to the grid via underwater cables. And here if you see from waveforms, around 30 megawatt per square kilometer, enough to power around 20,000 homes. So if you take like उसमें से wave farm से आपने 30 megawatts ले लिया तो भी it is enough for a small city, is it? And this is also like submerged type wind turbines hai. Not wind, like current, like water current turbines. So next is tidal power. So as we all know, tides are generated, like produced because of the position of earth, moon and the sun. Is तीनों की position. When they come in a line, like when the earth comes between the moon and the sun, high tides are generated. At the same time, when earth and sun are perpendicular to this moon, low tides are produced. So this time, this also is a continuous process. From that also you can generate the tidal power. and वो 5 to 10 meters की difference ही इसमें required है. So next is ocean thermal energy conversion. Like जो ocean में temperature difference है, जो top portion of the ocean and bottom, like जो bed है, ocean की bed है, वहाँ की जो temperature different है, उससे भी हम एनर्जी जनरेट कर सकते हैं. एंड यू कैन सी अराउंड 24 to 30 डिग्री सेल्सियस का डिफरेंस है इस दोनों का, टॉप रीजन एंड बॉटम का. सो दिस इज अ स्ट्रक्चर विच यू कैन सी हियर. सो ऊपर है हाई टेम्परेचर, लाइक वाटर का बहुत हाई नहीं है, इट इज अराउंड 20 to 30 डिग्रीज सेल्सियस, एंड नीचे इट विल बी कूलर. सो नाउ व्हाट इज डन, दी जो water है from the collar surface, it is taken here, it gets condensed, it's pumped and it goes to the upper surface, and the upper surface water is also entering and it exchanges the heat here. Okay, and there that heat is transferred to this, and the water will get converted into steam, and that vapor is used for rotating the turbines. Again, in the turbine, water get condensed and it comes back. Okay, so this is only the difference in water, the temperature in water is also utilized for generating power. Next is geothermal. So geothermal, as you all know, like exploiting Earth's temperature to produce electricity. So Earth के अंदर जो हमारे Earth crust में है, you have the rocks there, and it is around 4000 degrees C it is. So the rocks also melt, and वहाँ से जो rocks, melted rocks है, वहाँ से high steam will be coming out. So you can see this. छोटा सा ducts है, तो from there high steam will be coming out. So this steam can be used for generating electricity. So that you can see here, one of the real-time plant and the structure here. So in this structure, जो high steam है, so this this steam is taken up, it goes to a region where it is being exchanged. That steam is जो waste product है, it comes down and the steam is taken up and it goes to the turbine, it exchanges, like it does the useful work there, and that exists, and after that the steam is taken to the condenser, and there it gets condensed and the water is again going back. Like water यहाँ cooling purpose के लिए use कर रहे हैं, जो waste product है, it goes back again. The waste product is said to be the brine, so brine भी यहाँ ऐसे ही चले जाएगा, और जो cooled water है, that will also come down. Okay, so this is a general, like general structure of a geothermal power plant. Okay, so some of the advantages: reliable, the Earth's heat provides a constant source of energy, low impact on environment, and then the room for there is a room for improvement. Around now I just searched in 2013, 11,700 megawatt is being installed, and it is estimated that 15,000 megawatt will be there in 2014. So this was a Google से मैंने data लिया है. So around 11,700 megawatt is being generated using this geothermal plant. But the disadvantage of geothermal is, by say earth का crust naturally cool हो गया, then that area cannot be, once you have constructed, वो तो waste हो जाएगा. So earthquake may occur, then that plant is disturbed, and then building cost is there. So these are some of the disadvantages. And other thing is, जो geothermal area है, it may be far away from the electricity grid. It cannot always be said that grid के पास होगा. So these are some of the disadvantages of this geothermal power plant. Okay, but now it's almost 1, so I'm just winding up my lecture. And in the afternoon we have Dr. S. Chatterjee. He'll be giving you a lecture on energy management and conservation. Okay, mainly energy conservation में sir will be talking. So I just want all of you to assemble back at sharp 2:15. Okay, so sharp 2:15 we will reassemble again. So if you have any doubts, you can ask. चलेंगे हो टी ब्रेक्स के लिए, नहीं है ना? Okay. So I'll just show you this slide is there. Just see. So इसमें, okay, I thought I have put my slide share link, but slide share link is not there. This PPT I'll be putting in the slide share link, and otherwise I'll be sending you people also. So you will be getting a copy of this. Okay. So if you have any doubts, you can just contact me. My mail ID and phone number is there. And if you have any doubts, you can ask me now.